So going on to the lactate system. So the lactate system is using glucose or glycogen, so often known as glycolysis or glycolytic system. So its main fuel source is glucose and glycogen. So it's also going to produce ATP. So like that ATP, PC system, lactate pathway is anaerobic, which means without oxygen. So no oxygen is required. And here's just a little quick sort of graphic on it here as well. Its glycogen is present in the muscle cells and liver. Remember, as it's stored predominantly in the muscles, a little bit in the liver as well. Glucose is present in the bloodstream, and the glucose is broken down to provide energy and enzymes and speed up that process. And pyruvate is also produced, as you can see down here on the fourth line, the red there. Pyruvate is produced. But since no oxygen is available, it's converted into lactate. So lactate can be used also for energy. And why people often feel sick is you get hydrogen ions dumped into the stomach. If you've ever done interval training and felt like you wanted to vomit, it's because hydrogen ions are very acidic and they're a byproduct of this anaerobic metabolism. Then finally, we get into the aerobic system. Remember, this is the other system. So we have the anaerobic and the aerobic. So this is the aerobic system. And this one is using the substrates are glycogen and fat. So glycogen, stored form of glucose. This one happens after sort of 2 minutes plus, depending on the intensity of the exercise. It also depends on what you've got available in your system, what substrates. Now, we have lots of fat, but we always need some glycogen because your central nervous system's preferred source of energy is going to be glucose. So if you run out of glucose because you're doing a marathon and you haven't got enough, your brain will take priority and will start to shut down the rest of the system of the body. So you won't actually be able to perform. You'll collapse, etc. So this recovery time is 24 to 48 hours. Remember, it means you can still work in the system outside of that time, but it means you're not fully recovered. So it's long distance endurance events. So let's look down at the program here at the bottom. So pyruvate is also produced. Oxygen is available, so pyruvate is broken down to acetyl-CoA. It's created from fats, a process called beta oxidation. It goes through that Krebs cycle. You might remember this from chemistry, or sometimes called citric acid cycle and the electron transport chain. And we've got some byproducts here, CO2, so carbon dioxide, and we've got oxygen and also some water. So more energy is produced here. So lots and lots of ATP. Let's move on to what we need to eat to fuel our body, because we do need to eat our macronutrients. And this you'll need to have an understanding, because this is in your assessment 2B, which will be a video of you presenting. So how much you need really depends on how much you're training, how many hours a day, what's your type of training, is there muscle damage, etc. So there's a whole range of reasons why we eat different foods when we're exercising, and it depends on what someone's goals is as well. Let's start with carbohydrate and protein. So carbohydrate needs, and this is taken from the AIS, Australian Institute of Sport, also in your textbook as well. It depends on, this is for someone who is training. So if you're training, light intensity skill-based activities, you might need 3 grams of carbohydrate per kilogram of body weight per day, up to about 5. Now, some of you might go, well, that's quite a lot of carbohydrate. So this is someone who's being physically active and actually doing some activity. So you can have a look here. Depends on the amount of training. I understand that some people will be on a low carbohydrate diet, and if you're an athlete, that's something you need to really work on, that transition to be able to, rather than just swapping that carbohydrate out. And there is some evidence that people have been able to do this successfully. But these are the recommendations from the AIS, the Australian Institute of Sport, that we look at how much carbohydrate you need for exercise, and timing of nutrients are very important as well. And if you're interested in sports nutrition, we will be looking at more of this when we get into lifespan nutrition. We do a whole module on sports nutrition, and there's also an elective now as well, which is exercise and sports nutrition, which goes into a lot more detail of how much we actually need. So how much you actually need depends on the type of exercise you're doing. So if you're doing low intensity, I put those numbers up before, but it really depends on the type of exercise, but also how long your duration is going for. It depends if you're carbohydrate loading. So a carbohydrate loading, maybe for a marathon or a half marathon, we may be eating up to 10 grams per kilogram of body weight per day. And that would be the 36 to 48 hours before an event. So it's like you're stacking glucose in the cell, get as much as you can in the cell. And this may sound like a lot of carbohydrate to most of you, and especially if you have followed a low carbohydrate diet. These are what the guidelines are in terms of exercise and sports performance. Fats burn in a carbohydrate flame, but we do need some glucose in there, especially when we're doing these long distance events. But there's all guidelines in terms of that are very specific about how much carbohydrate we actually need based on the type of sport people are doing. So it is a very individual thing. So we want to make sure that we don't hit the wall because your nervous system shuts down from complete glycogen depletion. That's typically around 2 to 3 hours of intense exercise. So in this situation, we would be recommending a higher carbohydrate intake, preferably, for a few days probably before, and we taper our training down. So your volume of training decreases. So we taper it down so that we can up and saturate those tissues with glucose, etc. But again, this really depends on type of sport you're doing, the duration of it, and the intensity. So even with something like bodybuilding, bodybuilders actually need a little bit more carbohydrate in their diet, especially post-exercise. So post-exercise, we need an insulin spike to enhance muscle protein synthesis. So methods, this is carbohydrate loading. Again, this is from your textbook, worth having a bit of a look at. And I was sort of mentioning up to 10 grams, which again sounds like a lot of carbohydrate, but if you've ever done marathons and long distance event, you will understand. The other thing that's really important here is the timing. So we talk about a 1 to 4 hours before a race. So we're talking about like some kind of race here, might be a marathon or triathlon. You need 1 to 4 grams of carbohydrate per kilogram of body weight. We need an easy to digest low GI carbohydrate, so something that's not going to give you lots of gastric upset, not too much fat in there or fiber. And optionally, you can have like a snack 1 to 2 hours before an event. This is not recommendations before you go to the gym, etc. You just need to have had a mixed meal within sort of 2 or 3 hours or 4 hours before you actually go and train. Also, we avoid training on a completely empty stomach unless it is lower intensity. We want to try and have a little bit of something in the system so we don't want to go into too much gluconeogenesis where we create new glucose. Let's talk about protein. So protein requirements, this really varies on the type of training that you are doing. There's lots of different guidelines, and you will see what the National Health and Medical Research Council, their guidelines talk about, maybe 1 gram per kilogram of body weight per day. But I'm looking at and talking about people that are training. So if someone is trying to build muscle mass or maintain muscle mass, we go 1.2 grams up to 2 grams of protein per kilogram of body weight per day. Okay, so it depends on your type of activity. Typically, females need a little bit less as well, but it's based on someone's weight. This is a more accurate way of looking at it for someone who's, we're saying with carbohydrate, we base it on the person's weight. So we go grams per kilogram body weight per day. Higher protein intakes can go up to 2.3 to 3, up to 3.1. This is when someone is maybe bodybuilding, and especially someone who is really trying to increase muscle mass. So muscle protein synthesis, MPS, we really want to look at an acute dose of protein post-training of 20 to 40 grams. The other thing is very important that you spread the protein out throughout the day, rather than just having this big hit of protein, which lots of people do at nighttime. So they might sit down a big piece of steak. We want to try and have protein at each meal. It helps with satiety and it keeps the circulating amino acids, the building blocks of protein, circulating throughout the liver, etc. So, you know, we can have this acute dose up to sort of 20 to 40 grams post-training. If you can get a mixed meal in you after a training session, that's absolutely fine. You've got about a 45-minute window. But if you are a little bit delayed, have even 6 grams of protein will actually start muscle protein synthesis. So 6 grams could be like a boiled egg. So that's a great thing to have post-training. People often say, should I have branched chain amino acids, BCAAs? Look, if you're having whey protein, if you can stomach whey protein, whey has a full profile of a branched chain amino acids, especially leucine. Leucine is one of the BCAAs, branched chain amino acid, and it's the one that seems to have the greatest effect on muscle protein synthesis. Muscle protein synthesis is when you're building up. Muscle protein synthesis is when you're breaking down. Okay, it also is going to promote mTOR, which is that pathway that's going to help with muscle protein synthesis. So we also need some carbohydrates. Carbohydrates and a ratio of 3 grams of carbohydrate to 1 gram of protein will increase muscle protein synthesis. You increase this insulin spike. So insulin is a very anabolic and it helps you to make things grow. So look, there's a bit of conjecture around this, but everything that the guidelines are, if you have 3 grams of carbohydrate to 1 gram of protein, will enhance that insulin spike and also enhance that muscle protein synthesis. Look, it is quite complex what we do with in terms of what the requirements are. But, you know, if as long as we're getting sort of people to have at least 1 gram of protein, you may choose to have a higher amount of protein. Unfortunately, just having a high protein intake and not doing the exercise doesn't mean you're going to build muscle. You need to stress the muscles. So we need to load those muscles. We disrupt the muscle fibers. You go backwards before you go forward, so you don't train again in 2 days in a row, especially the same body part. We go backwards, we dismantle those proteins, etc. Then we go backwards and then we rebuild. So it is important to exercise if you are trying to build muscle, because unfortunately, as I said, just eating high protein will help you suppress a bit of satiety, but it's not going to help you build more muscles. Unfortunately, wish it was true. So yeah, there's your general guidelines, as you can see here. 0.75 for females, that's grams per day, that's per kilogram of body weight per day, by the way. And you'll see for men. So this is what the guidelines are, and you'll see that in textbook. But if you're interested, there's a lot of great information on the AIS website, the Australian Institute of Sport. Even the International Society of Sports Nutrition, they've got some great information. There's lots of good research available. All right, protein as fuel. Factors affecting protein use during activity. It really depends on if you've got a little bit of carbohydrate, it can spare protein, because we don't want to use protein as an energy source. It can be used as an energy source, but that's if you don't have enough carbohydrate present. So that's why it's good to have your meals with protein and carbohydrate, because it's going to help to spare the protein, because we want protein for repairing the body, but also to rebuild muscles if we're looking at fitness, etc. When we're doing aerobic endurance activity, we're going to deplete those glycogen stores, and the body can rely on protein for energy if you don't have enough there. So through that process of called gluconeogenesis. When we're using for anaerobic strength training, we don't use more protein for energy, but it demands more to build muscle. So it really depends on type of training, person's physique, their what gender, and also how much muscle mass they have and what their type of training actually is. That's what's really important. So it is important for, it's not a major source for fuel, but its primary role is building tissues and repairing tissues. It can be used as a source, but it's not the best possible source. But as I said, it can be. So just remember, proteins are the body's building blocks. It's found in all living cells. They have functional and structural properties, and they're composed, and they're all different. Remember, they've got those side chains that are all quite different in terms of the amino acid profile. All right, let's go on to talk about some of the guidelines for physical activity for Australians. So I was mentioning earlier that we need to do a thing called the FIT principle. So the FIT principle is frequency, intensity, time, and type. And this is very much based on someone's age. And there are guidelines for 5 to 17-year-old. If you'd like to look at these guidelines, they're from the Department of Health. If you search the Australian guidelines of physical activity, you'll see there's guidelines for 5 to 17-year-olds. And what we do recommend for that age group is that they need to be physically active for 60 minutes, at least 60 minutes. Not less than 60 minutes, should be more than 60 minutes of vigorous activity every day, including a variety of aerobic activities. We want to limit sedentary behaviour and use of electronic equipment. So unfortunately, kids now are all doing, they're all on devices non-stop. They get home from school, they've been on a device all day and they're back on another device. We want to sort of break that up with periods of doing movement rather than just sitting for long periods of time, ensuring they're not taking their phones into their bedrooms, hopefully not, because they can be on them when you think they're actually asleep. We want to ensure that they have good quality sleep. We also want kids to do some activities that strengthen their muscles and bones. So some body weight movements, things like sit-ups and push-ups and sit-ups, anything that's getting kids playing. Sport is great. We can have children in sport because it also fosters that teamwork, but it also gets them moving in lots of different planes of movement, lots of different muscle groups are used, and often kids, they have a good time. I understand, some children find it very difficult doing team sports because of maybe their size, and maybe they're a little bit larger for size, and they find that they never wanted to do physical activity. So for 18 to 64-year-olds, and can, as said, look at these guidelines, we want people to do at least 150 to 300 minutes per week. So that could be walking, swimming, and it doesn't have to be in one go, obviously. You can break it up. And we used to say it's better, you can do it every second day, but now what we want to do is be active most days. That's preferable. Most days of the week, people are active. We also want people to incorporate muscle strength activities on at least 2 days a week. So I'm going to ask you all, are you doing something that's muscle strength activities on at least 2 days a week? Because that's what the guidelines are to help to build strong, healthy bones and also support your immunity. Because if you've got muscles, it's going to help with your immune system as well. So there's what your guidelines are for the 18 to 64-year-olds. When we get to the next age group, they change slightly. For the over 65s, we want them to do physical activity, regardless of their age, their weight, their health problems, ability. We want people to move, and we want them to move in as many ways as possible. We want them to do fitness, so cardiovascular, something to get their heart going. Walking's great. Doing some strength training, as you can see here, the picture here, people are strength training, doing some balance and flexibility. Now, this is where it changes. As people get old or older, they lose the proprioception of where they are in space, and they lose their balance. And balance is interesting because if you don't challenge your balance regularly by standing on one leg, you will lose that ability. So you'll lose your balance. So it's something you need to work on all the time. So it's a little activity you can do at home is stand on one leg, see if you can hold it for 60 seconds and close your eyes. Maybe just make sure that you're not going to fall over onto anything. The other thing is flexibility is important because we lose our range of motion as we age around the joints. So it's important that we have, we do this flexibility regularly because it just really, really helps in terms of keeping that, so we keep injury free, and accumulate at least 30 minutes of moderate intensity physical activity on most days of the week. All right, that brings us to the end. And just finally, just to recap some of those benefits of fitness: reduce or restful sleep, improve body composition, improve bone density, improves your immunity, low risk of some cancers. We can go back through the beginning of this lecture. We talked about the different types of cancers, decreases NCDs, non-communicable diseases, low risk of type 2 diabetes, reduced risk of gallbladder disease, improves cognition, so brain function, also improves the neurotransmitters, so you're feeling better in terms of your serotonin levels, dopamine levels, strong self-image, long life, high quality life later in years, and also less incidence of fall, because what we find is if people fall and break a hip when they get older and they go to hospital, because their immunity can be compromised, then we often find that they might pick up something in hospital and maybe they don't come home from hospital. So we want to keep people physically active, also keep them independent as well as they get older, and less chance of falls. All right, that brings us to the end. Just a reminder that your quiz does open in week 4, the end of week 4, and it's only open for 1 week. So good luck, everybody.